All right, students, hello. This is video 1.3. The objective is for you to say, I can find and compare lengths of segments. So let's get started with our definitions. First thing we're going to do is look at what the length of a segment is. So here is the definition. Length is the absolute value of the difference between the coordinates of the endpoints. Okay? So say we have a segment. And here we do. We have a segment, AB. It's on a line. We know that this is a segment because these are two endpoints, and we know that we can represent this by actually writing this segment as segment AB. If point A is at -3, say on the number line, and point B is at 5, then the length of the segment is actually defined as this space between these 2 points, okay? And that's always going to be a positive value. Because math always has its fancy notation, it's really important to look at the notation for the length of AB. Now, I know when we talk about AB, the segment AB, we use the symbol, the line over it, and then the 2 letters, the capital letters. But when we're talking about the length of AB, it's just going to be AB. And that can be a number. That can be 5. That can be 27. That can be whatever it is, okay? As long as it's a positive number. Length is always going to be some number, okay? The segment addition postulate is something that's really cool. It's something that you will use again and again throughout your study of geometry. And what the segment addition postulate basically says is that the length of a segment equals the sum of the lengths of the segments from which it is comprised. AKA, if you have a segment, AB, here's AB, and you add it to BC, then it will equal the entire thing, AC. So if you add AB, so if we add together segment AB and here's segment AB, plus segment BC here, then we will have segment AC. And that is basically the segment addition postulate. Okay, so let's look at example 1. Example 1 has segment KM, and it's clearly been separated into 2 pieces. It's been separated into KL, and it's also been separated into LM. We can see those pieces here. So according to the segment addition postulate, which says if you take a piece plus another piece, it will equal the whole thing, we should be able to solve this in that way. So let's actually just write that out. KL plus LM should equal KM. And then let's actually just substitute in here. So KL is x plus 0.5 plus LM, which is 3x minus 2. And all of that equals, at the bottom, if we look here, 3x plus 1.5. Let's write that in. 3x plus 1.5. So now this is algebraic, and we just want to solve it. So we've got 4x's here, plus 0.5 minus 2. When we combine these two, we're going to get negative 1.5. Then we're going to get 3x here plus 1.5. And all that equals this. I'm going to subtract 1.5 from both sides. That's going to give me 3x equals 4x minus 3. I'm going to subtract 4x from both sides. Which is going to give me 1x negative and negative 3. Then I'm going to be dividing both sides by negative 1 because I don't want x. I don't want negative x. I want positive x. So x now equals 3. So that means that they wanted me to find the measurement. So now that x is 3, I can go back and say, well, this is really KL. This piece is really 3 plus 0.5, which is just 3.5. That's really cool. Then this other piece over here, 3 times 3 minus 2 is going to give me 9 minus 2, which is 7. So very clearly, KL equals 3.5, and LM is going to equal 7. Next question, number 2, says, draw a picture of the following situation. Point B lies on AC, that's here. So it's actually supposed to go here, and then between A and C. So here we're going to make a segment, and we're going to call it segment AC. And as long as you put B on this segment anywhere you want, I mean, you can put it here, you can put it here. It really doesn't matter where you put it. That would be true. Okay? Number 3, using the picture below you drew in the last question, if AB, so let's make AB again. If AB is 5 and BC is 10, then what is the length of this entire thing? Again, this goes back to the idea of AB plus BC equals AC. So 5 is AB plus BC, which is 10, will give you 15 for AC. And that's the segment addition postulate again at action. Last but not least tonight, here is your secret hot question. That is actually not your secret hot question. I'm going to fix this. Just give me a second. Your secret hot question for tonight is going to be something different than this. So as you see me cross this out, please ignore it. What I want you to do is I want you to tell me what is the segment addition postulate. What is it? What is that weird thing? What is the segment addition postulate? Please remember to post your answer on the Google Doc. Later, dudes.